Hello, welcome to Astronautic for Exploit. This is Dr. Ayeshola Ogunele. Celestial and space robots, indispensable tools for humans' ability to explore further into the deep space and unexplored regions. The focus points are as follows: Celestial and space robots, robots versus astronauts, space robotic helpers, and future of celestial space robots. Space, the final frontier, has been humanity's source of inspiration and curiosity since the dawn of age. In the 1966 to 1969 Star Trek science fiction television series that described the mission of the Starship Enterprise, William Shatner, who starred as Captain Kirk, was credited with the first use of the space being referred to as final frontier, where no man has come before. Celestial and space robots, electronic systems designed and developed to assist humans on space missions or replace humans in complex space missions, are enabling humanity to perform space tasks that cannot ordinarily be performed by human beings or are too dangerous for human beings. The first space robot to be sent to space was Sputnik 1, which was launched on October 4, 1957. After then, several celestial and space robots have been sent to space and are being prepared to be sent to space to explore celestial bodies such as Sun, Moon, Venus, Jupiter, Mars, Mercury, Saturn, stars, moons, asteroids, comets, Kuiper Belt, dwarf planets, nebulae, and galaxies. In order for astronauts, various space robotic helpers have been developed. Examples are Astrobi, Sansi mission, gecko-inspired adhesive grasping, Robnot, and Zymo. Astrobi, a free-flying space robot with the capability to navigate around the International Space Station autonomously, was designed to assist astronauts on the ISS. It can work autonomously via remote control by astronauts, flight controllers, or researchers on the ground in order to complete tasks such as taking inventory, documenting experiments conducted by astronauts with their built-in cameras, or working together to move cargo throughout the station. SANSI, a new space technology and a space-band model from Bosch, was designed to experiment with AI and audio analytics in order to enhance monitoring on the International Space Station. Celestial and space robots. Space robots are specialized robots that replace humans in conducting scientific experiments, external vehicular activities, space exploration, and other activities in space. The traditional modes of space transportation, on-orbit construction, on-orbit maintenance, and planetary exploration are being changed by the space and celestial robots. The picture here shows Romanov's robot moving for the first time aboard the International Space Station. Space robots are one of the important enabling means for future unmanned and manned space missions. Presently, practitioners from different endeavors, such as physicists, chemists, biologists, computer scientists, engineers, and other specialists, are collaborating to develop state-of-the-art space robots for better navigation of our space environment. The picture here shows Regolith Advanced Survey Systems operation robots. Space robots, rovers, or mobile spacecraft are specifically designed to assist or replace humans on space missions. They are created so that their physical form, size, and the materials they are made of are robust and can perform all kinds of tasks with high precision and flexibility. The picture here shows Spidernaut, NASA's Arachid robot prototype. Robots versus astronauts. Robots and robotic missions are increasingly becoming vital components of space exploration and space economy. Robots have advantage that they can be sent to destinations currently unreachable for humans, such as the outer planets, their moons, and even interstellar space. This allows for a greater breadth of scientific exploration. Humans and robots exploring space is shown in this picture. Robotic missions are generally less costly and risky than manned missions. Robots do not require life support system, food or water. They can withstand harsh conditions such as extreme temperatures, radiation and the vacuum of space. Robots can function in space for extended period of time. For instance, Mars rover Spirit and Opportunity far outlasted their planned operational lives. This long-term exploration capacity provides ample opportunities for scientific discovery and data collection. The picture here shows NASA's Falcon humanoid, which was designed for Mars exploration. Space robotic helpers. Space robotic helpers are built in order to help astronauts to work in space. Astronauts' time is a valuable resource on the International Space Station, and its value only increases for future space missions. One way to make the most of crew time is using robotic technology, either to assist crew members with various tasks and or to completely automate others. Atlas robot with 3 wheels climbing a hill is shown in this picture. Examples of space robotic helpers are Astrobi, Sansi Mission, Gecko-inspired adhesive grasping, Robnot, and Zymo. Astrobi, a free-flying robotic system, was designed to help astronauts reduce time they spend on routine duties, leaving them to focus more on the things that only humans can do. The picture here shows Xenon floating inside the International Space Station. Astrobi robots are designed to complete tasks such as taking inventory, documenting experiments conducted by astronauts with their built-in cameras, or working together to move cargo throughout the station. Astrobi serves as a research platform which can be outfitted and programmed to carry out experiments in microgravity, helping humans to learn more about how robotics can benefit astronauts in space. The picture here shows one of the Astrobi robots performing a self-toss or open maneuver for the astrobautics investigation. Sansi mission demonstrates using sound to monitor equipment on a spacecraft with a sensor mounted on an Astrobay. The sensor detects anomalies in the sounds made by life support system. Results from Sansi mission highlighted the difference between simulations and in-space experiments. The picture here shows Sansi robot, which was designed to make life easier for astronauts. Gecko-inspired adhesive grasping tested an adhesive for robotic grasping and manipulation using a special gripper on an Astrobay. Geckos are a type of lizard that can grasp a smooth surface without needing features such as nicks and knobs to hold on to. Adhesive grippers inspired by these reptiles, already proven to work in space, could allow robots to rapidly attach to and detach from surfaces. Artist illustration of gecko gripper system is shown in this picture. GEM Internal Ball Camera 2 is a free-floating remote control panoramic camera first launched to the space station in 2017, and this investigation from JAXA demonstrates using the camera to autonomously capture video and photos of research activities. GEM was designed to reduce the amount of crew time devoted to taking video or photos. The picture here shows NASA astronauts Woodson working with the GEM internal ball camera. Sphere, which was used Berlin ball-sized spherical satellites to test formation flying and algorithms for control of multiple spacecraft, as well as to host physical and material science investigations. The technology was able to handle increasingly complex scenarios that added static and moving obstacles. The picture here shows an astronaut monitoring a pair of free-floating satellites known as spheres. Future of celestial and space robots. Robots have greater potential for use in space exploration. Also, in future, balanced approach of using both astronauts and robots will help in breaking the boundaries of space exploration. Examples of future use of celestial and space robots for exploring space are robotic precursor, telepresence and telerobotics, in-situ resource utilization, space infrastructure, and economy. Key robots aboard the space station is shown in this picture. In the future, space robots are being planned to act as precursors to human missions, assessing the environment, potential hazards, and points of interest. Using robots as precursors will make subsequent manned missions safer and more effective. Curiosity Mars rover is shown in this picture. The combination of human cognition with robotic capabilities can be achieved through telepresence and telerobotics, where astronauts control robotic systems from a remote location. Telepresence and telerobotics approach is already being used on International Space Station. NASA's solar-powered Mars helicopter is shown in this picture. Robots can be used to set up infrastructure and start using local resources before human arrival, a concept which is known as in-situ resource utilization. ISRU will enable human missions to be more cost-effective. An artist concept portraying a NASA Mars exploration rover on the surface of Mars is shown in this picture. The commercial space sector is growing and there is a need for both astronauts and robots. Humans are needed for tasks requiring complex decision making and dexterity, whereas robots can perform repetitive, hazardous, or long duration tasks. In the future, space-based industries like satellite servicing, space manufacturing, and asteroid mining could benefit from a combination of human and robotic labor. Sharon rover is shown in this picture. For more information, contact Astronautic for Exploit. You've been listening to Celestial and Space Robots, indispensable tools for humans' ability to explore further into the deep space and unexplored regions, presented by Dr. Ayanshola Ogunere, with the focus points Celestial and Space Robots, robots versus astronauts, space robotic helpers, and future of celestial and space robots. Thank you.